In this video, we're going to not do the SAT question. Okay, that's something we would have done in class. We'll review how to factor trinomials when a is equal to 1. Remember, the trinomials we're talking about, I should probably say quadratic trinomials, because they're going to be, for the most part, x squared equations. And we're going to look at first when a equals 1, so you have a lead coefficient of just 1, so it'd be 1x squared or just x squared. So something like this. And then we'll also look at number 3 there. What happens if you have a coefficient like 3x squared minus 2x plus 8 equals 0. So here the a value is 1. Here the a value is not 1. So it could be any number other than 1. So here is note sheet number 6, or page 6, solved by factoring in quadratic form trinomial. So this ax squared plus bx plus c equals 0. A is 1, so you can see right there. Now, the way you're going to factor it when your a value is 1 is just always make, when you got this quadratic, 3 terms, make 2 sets of parentheses. It's always going to be x and x, or whatever this variable is right here. And then you have to figure out what r and s are, such that r times s equal your c term. That's the constant of the trinomial. And r plus b, let's go ahead and color code these things a little bit. So we'll do this in blue, c. They've got to equal this when you multiply them. But they've got to add up to b. That's the term right there. So let's look at how we do this. So here's my quadratic trinomial, standard form, x squared, x to the first, no x's. Okay, it's got 3 terms. Its lead coefficient is just 1, so immediately make 2 sets of parentheses. Bump them right up next to each other there. That means they're multiplied together. This first term is always going to be x and x. And whatever goes here, your r and your s, they have to multiply to equal 24, the c term, this last term right there. And so you make a list and you go 1 times 24 and 2 times 12 and 3 times 8 and 4 times 6. And you stop at any point when you recognize a pair of numbers who, when added, could equal the negative 11 in the middle. That's this has to equal b. Okay, so that 8 and 3 could equal b if they were both negative. That's fine and dandy to make them both negative, because now they do add up to negative 11, but they still have to multiply by 24. Well, since they're both negative, negative 3 times negative 8 is positive 24. So these are your factors that go right in there. Negative 3 and negative 8. So there's the factorization for it. And once you get it factored, I think it's always a good idea. You need to always go back and just kind of mentally check to make sure your factorization is correct. So how do we mentally check it? Well, first of all, when you distribute here, if you remultiply these, you distribute the x. That first distribution should give you your first term, x squared. The 24 you check by doing the last terms. Negative 3 times negative 8, that gives you the 24. It's the middle term that people get confused about and where it comes from. Well, that comes from this product when you distribute, and this product when you distribute, and that's a negative 8x and a negative 3x, and they do add up to the negative 11 in the middle. Okay, so once you have it factored and you know it's factored correctly, set each factor equal to 0 and just solve them. So x is 3 is one solution, and then x minus 8 equals 0, so x equals 8 is the other solution. This was quadratic, should have 2 answers, and we found them. Next example. Okay, notice how this one does not equal 0. So we've got to get it equal to 0 first. In this case, we add 2 to both sides. Here they cancel out now. And so there's our starting point. Equals 0 right there. And we go, oh, okay, a value is 1, so I'm going to make 2 sets of parentheses. I got a trinomial here. Okay, x squared, so it's got to be x and x. I got 24 here, so they got to multiply to 24. It could be 1 and 24. We've seen a bunch of these before. 1 and 24, 2 and 12. I'm liking the 2 and 12 because they have a difference of 10. Now, see here, to get negative 10, it had to be negative 12 and positive 2. The problem is, if I do that combination, they do not multiply to a positive 24. 2 times negative 12 is negative 24, so that's not going to work. Even if I switch my signs, they wouldn't work. They can't both be negative because then they add up to negative 14 instead of negative 10. So I'm going to nix that. 3 times 8 doesn't work. 4 times 6, they add up to 10. Now they got to add up to negative 10. Okay, right there. So I'll make them both negative, and now they multiply to a positive 24. Oops, that should be a 6 right there. There you go. And I could check it again. Again, I'm going to mentally check it, but I'll walk you through my mental check. See, x times x is x squared. Negative 4 times negative 6 is positive 24. Negative 6x, negative 4x. That adds up to negative 10. I'm correct on my factorization. I set each one equal to 0 and solved it. And our very last one here doesn't equal 0, so I got to add 8, not 8n to both sides. Now that 8n doesn't have any like terms. It actually is the middle term, the b term. So I want to put it there so I'm in standard form. And now I've got an n squared out front, so I'll just start factoring it. 1 and 15 to get 15, or 3 and 5. I clearly want the 3 and 5 because they add up to 8. And I've got my answers, negative 3 and negative 5. Important to realize, everybody, these answers, the thing that makes this 0 and the thing that makes this 0, make this original equation up here true. Okay, so I could take any of these, either of these two answers, let's say the negative 3, which just happens if I put in negative 3. Here's just the left side. You can see it's negative 3 squared plus 15, so 9 plus 15 is 24. The right side, if I put in the negative 3 there, negative 8 times negative 3 is 24. So that's the n value that makes the left side, n squared plus 15, equal the right side, negative 8n. Same thing goes if I plugged in that negative 5 that I had. So that's how we solve these trinomials, by factoring when our a value is a 1. Now the other option is what happens if our a value is not a 1. So here we have the same page as before, solving quadratic form trinomials here, but a does not equal 1. So you can see in the first example, a is a 6, a is a 10, a is a 15. It's always the number in front of that x squared when we're dealing with quadratics. So let's go about trying to solve this. Now, when we try to factor something like this, we could go ahead and say, oh, it's a trinomial. It's probably going to factor into these two binomials. The problem is, because this 6 out here, we don't know if it's 6b times b, or if the first terms are something like 3b and 2b, because both those multiply. This pair multiply to 6b squared, and so does this one. So we don't know what goes in the beginning spot of each binomial. Also, we don't know what goes in the second spots. And in fact, here I've written it could be 1 and 6. But I should also consider, in fact, let me erase my other one there. I should also consider what if it is reversed and the 6 is here and the 1 here, because they give me different products. So if I put my 6 out here, I get this distribution, 36. Whereas if I put my 1 there, I get just a 6b. Okay, so it's a little more complicated. And in fact, in order to figure them out, you actually have to test them all. So you can go like this, 1 and 6. And I know when I chose that pair, I know that the 6b times b is 6b squared. I know the 1 times 6 gives me 6. I'm just checking this product, 36b, and this product, 1b. Well, 36 and 1 don't add up to 13. So then I can try to flip-flop these two and go 1 and 6. Oops, 6 and 1. Now this product is 6 and this product is 6, but they don't add up to negative 13 either. So that just takes care of the 1 and the 6. Now I also have to try the 2 and the 3 because they multiply to 6 also. This product is 18, this product is 2, they don't add up to 13. So I flip-flop my 3 and my 2. Now check, this is now 12 and this is 3. They don't add up to 13. That's all my possibilities, 1 and 6, 3 and 2. And now I try that same pair with this combination out front. See here, this is 18, this is 2. 18 and 2 don't add up to 15. So I'm going to flip-flop my 6 and my 1. This is 12 and 3. 12 and 3 don't add up to 13. So I'm going to try 2 and 3. This is 9 and this is 4. 9b and 4b. They add up to 13 if they're both negative. So I know the 13 comes out right. I check my first term, 6b squared. I check my last terms, positive 6. So there's my factorization. Now, you can see that all that trial and error takes quite a bit of time. So when our a value is not equal to 1, we had another method, or we have another method we could use. That's just kind of a gimmick method that always works. What you do is you first multiply your a times c. When your a is just 1, it never changes anything, so it's just c, and that's what we use. But when our a is not 1, in this case it's a 6, and our c is also a 6. This is a, this is c here. We get 36, and how we factor it then is 6b plus r, 6b plus s. The 6b is coming from this first term here. Now our r plus s, instead of adding up to c, our r plus s now add up to ac. Sorry, that should be r times s. Remember, these last pair, the product will give us 36. And r plus s has to equal our b again. Still this negative 13. So now I'm going to just find all the r's and s that multiply to 36. See here, 1 and 36, 2 and 18, 3 and 12, 4 and 9. There's a pair, 4 and 9. They add up to negative 13. Oops. If they're both negative. And they multiply to positive 36. And so this factorization, 6b plus r and 6b plus s, I'm going to erase a little bit here. So I'm going to write 6b plus r, my r is this negative 4, times 6b plus s, my s is negative 9. And then you have to check to see if they both simplify in each binomial. So in this binomial, each is divisible by 2. In the second binomial, they're both divisible by 3. And you can see by doing this process over here, there's my factorization. Compare that to what I did when I did it by hand and going through it by that trial and error method. You get the same answers. So this r times s method is very effective because you don't have to play guess and check so much. So I encourage you to use that method. So let's try it on this guy. First step, get the darn thing equal to 0 and in standard form. So here we have to subtract the 27x but add the 18 to both sides. So the left side will subtract the 27 and we'll also add the 18. The right side has now become 0. So we've got our a term, this 10x squared. We got our b factor, or b term there, the negative 27, and there's c, 18. So let's go ahead and find a times c. That's it. 10 times 18, 180. So it's going to factor as 10. Again, steal that a value. And 10. And we just got to figure out what r and s are now. So r and s has to equal that 180. But at the same time, they got to add up to b, which is negative 27. Let's see here. Things that multiply 180 with a difference of 27. 2 times 90. See, 3 times 60 doesn't work. 10 times 18 is close. 10 and 18 add up to 28. Let's see here. 12 goes in there 15 times, I think. See, 12 times 1. Yeah, 12 goes in there 15 times. And 15 and 12 add up to 27. So if they're both negative, they will add up to negative 27. And 12 times 15, let's just double check to make sure that multiplies to 180. Oops, 10 carry your 1. That's a 6 right there. Yeah. It multiplies to 180. It adds up to negative 27. So I go minus 12, minus 15, and simplify each one. Divisible by 2. Divisible by 5. Let's check it to see how we did. 5x times 2x is 10x squared. I still use the one in blue here. Negative 6 times negative 3 is that positive 18. Outside product, negative 15. Inside product, negative 12. And those two add up to negative 27. So there's my factorization, and I'd forgotten in all my haste to solve my equations in the previous example. So I'm going to solve this, and then I'll go back and solve the other one. Just set each factor equal to 0. In this case, I add 3 and divide by 2. Like I said, I didn't solve this one up here, so I would set 3b minus 2 equal to 0. That gives me b equals 2/3. And I'd set 2b minus 3 equal to 0. And that gives me b is 3/2. So that would be our solution for that one. Last example on trinomials in quadratic form. Let's get this thing set up. Let's see here, add 7x. So that's plus 4x, and then subtract 3. So here's what I'm trying to factor. And so I'm going to multiply, well, I'll just go like this. I'll go, okay, my a is not 1, so I'm going to write down my 15x. A times c is 15 times negative 3, or negative 45. So I need the numbers that multiply to negative 45, but they have to add up to equal 4, the b term. I'm thinking right off the bat 5 times 9 is 45, and to get to be a positive 4, I want the 9 positive and 5 negative. Now they add up to 4, and they multiply to negative 45. So I put in my 5, I put in my 9, or my negative 5. Divide by 5, divide by 3. Check it. 3x times 5x is 15x squared. Negative 1 times 3 is negative 3. Outside 9, inside minus 5. 9 minus 5 is 4. There's my factorization. Set them equal to 0 and solve them. Add 1, divide by 3. Subtract 3, divide by 5. And we get 2 answers. So that's how we solve them. We got 2 types that we just learned how to solve. Both of them quadratic trinomials, x squared equations with 3 terms. And if the a is 1, write your 2 parentheses and factor it. If your a is not 1, multiply a times c to begin your factoring. All right, that should take care of it.